Okay, welcome back again. Now all I want to do is continue with session 4, okay? So we've previously seen this already, so I don't want to spend too long talking on it. Okay? And here we are, this is our outcome. And we're going to be looking at resistance. Now that is resistance in respect of the resistivity of certain types of materials. So please bear that in mind. Resistance in respect of resistivity of certain types of materials. Okay. Okay, welcome back again. Okay, all we're going to continue with now is section 3. Okay, so I don't need to do a lot of talking here on this page. So if I can... Sorry about that. Okay, sorry about that. Okay, sorry about that. Something else just tripped in. Okay, but I'm going to continue anyway because it's only a short video. This one is okay. So now here, what we have here is it's just showing you the resistivity of materials. Okay, overall, let's just get that into here so you can see what it's trying to say. Okay, I'll come back and let's make sure we can get all these bits in as well. And I'll pan back so we can get full in. Okay. Right, now resistance is measured in ohms and its symbol is omega. Electrical resistance is a measure of the degree to which an object opposes the passage of an electric current. Okay. When any material has an electrical supply connected to it, it has a particular resistance. This resistance is called the resistivity of the material or its specific resistance. Okay. Okay. And here we have a list of resistivity of materials. Okay, resistivity of common materials. Okay, copper is 1.67 times 10 to the minus 8 ohms per meter. Okay, that's its resistance. So it has a very low resistance. You can see that glass, silver is 1.6 times 10 to the minus 8. Lead also has a low resistance. Aluminium also have a low resistance. Okay, now if you go to glass, it has a resistance of 1 times 10 to the 5. Okay, magnesium oxide is 1 times 10 to the 7, and perspex has a very high resistance, 1 times 10 to the 13. Okay, resistivity values are set for a particular temperature. If the temperature changes, so will the resistivity. So resistance needs to be quoted to a particular temperature. Okay. Let me see if I can bring that bit in for you. Okay, at the bottom. Make sure we can get it. Okay. And I'll pan back a bit. Make sure we get this fully in. Okay. Okay. Thank you. Sorry about that interruption we had a little earlier. Okay, right, thank you. Have a good day. Well, hang on. I think that's it. Bear with me for a moment. Just check. One more to go. And here you have your specific resistances, okay? This is R equals rho L over A. R equals resistance in ohms. Rho equals resistivity in ohms per meter. L equals the length in meters, and A is the cross-sectional area of your conductor in meters square, okay? Increase the length, increase the resistance. Now, if I was going to use 1.5 millimeter cable over 10 meters, that would have a specific resistance. If I then wanted to double the distance and make it 20 meters, therefore that resistance will also increase. So therefore I might use, rather than use 1.5 millimeter cable, I might then decide to use 2.5 or go up to 4 mil, depending upon what I was installing. Okay. Right, that's it. Let me just check that I haven't missed anything out. Okay. No, that's it. Thank you. Good. Well, I hope you found this useful again, and have a good day. Bye bye. Let me just make sure we bring it into view. Thank you.